The Sélune River had been cut in two for an entire century by a concrete wall rising 118 feet high, turning the upstream zone into an area of biological collapse. To restore the ecosystem, Europe decided to invest 50 million euros to completely dismantle that structure, releasing 2 million cubic meters of anaerobic mud directly into a watershed stretching 56.5 miles. Leading research institutes asserted that the river would need a minimum of 10 years to re-establish its basic circulation functions. But all of those scientific forecasts were completely overturned. The moment a gap appeared in the physical barrier, animal populations isolated for 100 years immediately swam upstream, restoring their habitat at a speed that astonished all of Europe. How could wild creatures instantly locate the exact route and push through 2 million cubic meters of dense mud? The survival mechanism that broke through every time limit humans had ever set on paper will be decoded right now. In 2024, the European Union officially activated the Nature Restoration Law, releasing a dataset confirming that 542 artificial barriers on rivers had been completely removed within a 12-month cycle. The core focus of this law is aimed at one enormous physical objective: freeing 15,534 miles of uninterrupted river flow across the continent by 2030. The origin point of this entire legal shift began from a single set of coordinates, the Sélune watershed in Normandy, France. Before 1914, the Sélune flow system operated like a high-speed biological route. The elevation gradient and continuous cold water provided a direct migration corridor for migratory fish species. Atlantic salmon, European eels, and especially the sea lamprey, a creature whose primitive genetic structure has remained unchanged since prehistoric times, depended completely on this route. They were forced to move from the saltwater of Mont Saint-Michel Bay, traveling 56.5 miles of uninterrupted current to reach freshwater gravel beds in the upstream zone in order to reproduce. The artificial wall began when industrial concrete casting technology rose to power. From 1914 to 1932, two hydroelectric structures named La Roche, Quiboit, and Vezins were built directly across the riverbed, completely blocking the force of the current. The Vezins Dam stood 118 feet tall and stretched 912 feet wide, built from tens of thousands of tons of interwoven reinforced steel. It was not merely a power station. It was a wall that completely severed 435 miles of upstream watershed. The massive volume of trapped water formed a still reservoir, completely cutting off the traffic flow of the ecosystem. More seriously, the blocked current caused the water to lose its ability to carry drifting material downstream. As a result, 2 million cubic meters of coarse sediment accumulated behind the concrete wall. This sediment layer was not merely natural earth and stone. Geological testing by specialists confirmed that it was a vast mass of mud containing heavy metals and anaerobic microorganisms. This layer of mud covered the original riverbed completely, wiping out the gravel spawning grounds of aquatic animals and forming a lifeless buffer zone. This fragmentation of river flow by the concrete megadam triggered a chain reaction. Altering the movement mechanism of the water was about to activate a radical transformation in chemical composition on a massive scale. The closed dam gate system locked the migration route shut. Biological records show that Atlantic salmon disappeared completely from the 435 miles of upstream habitat in the very first spawning cycle of the 20th century. Measurement stations in the downstream zone recorded the number of adult salmon dropping to the minimum level needed to sustain the population, fluctuating at only 200 to 700 individuals trapped in the narrow waters below the dam. But the disappearance of fish was only the first stage of the decline. When the natural force of circulation was neutralized, the mass of water in the Sélune River shifted into a state of thermal stratification. The surface layer of the artificial reservoir was exposed directly to solar radiation, causing temperatures to surge beyond the physiological threshold of temperate water species. Meanwhile, the deep water near the bottom became trapped together with the sediment layer. Still water conditions, high surface temperatures, and the buildup of chemical nutrients created the perfect reaction environment for one microscopic organism to dominate cyanobacteria. The mast cell division of cyanobacteria immediately consumed the dissolved oxygen throughout the water system. The wide reservoir surface turned into a dense green layer, completely blocking sunlight from penetrating to the bottom. Oxygen depletion caused native fish species to suffocate. The upstream section of the river quickly turned into a dead water zone. Extreme summer temperatures stimulated cyanobacteria to release biological inhibitory agents directly into the water environment. The concentration of these substances exceeded safety thresholds, forcing regional authorities to issue a swimming ban and permanently suspend all direct contact activity on the reservoir surface. This chemical and biological lockdown continued for 100 Earth cycles. Migratory fish populations were compressed into the downstream foot of the dam, relying on narrow water gaps to maintain a minimal number. This biological stagnation remained in a frozen state until pressure from the European Union created a direct conflict between economic infrastructure and the demand for natural restoration. Dismantling a concrete structure that had operated for 80 years was not just a mechanical issue. It was an administrative battle that lasted exactly 23 years. From the first scientific measurement report calling for removal in 1986, proposal documents were repeatedly ignored by regulatory authorities. Artificial fish passage ladders added in the 1990s proved completely ineffective against a barrier standing 118 feet high. In 2007, the power operator officially published a technical report confirming that the dam structure was incompatible with the requirement for ecological continuity. However, the existence of the reservoir had created an economic system tightly tied to the region rowing clubs, waterside property values, and agricultural irrigation networks. The dam removal project was suspended, restarted, then suspended again because of opposition from local economic interest groups. Only when the European Commission intervened directly and threatened to impose strict financial sanctions under the Water Framework Directive was the physical implementation process finally activated. In April of 2019, the largest artificial structure removal campaign in Europe officially began. Every option involving industrial explosives was rejected immediately. Blasting a wall 118 feet high would have released 2 million cubic meters of highly contaminated sediment instantly, creating a wave of material that would completely alter the downstream zone and the estuary. Instead, the operating engineers applied a mechanical dismantling technique. Industrial machines were brought to the top of the dam and removed the reinforced concrete in thin layers. The water level in the artificial reservoir was lowered step by step under extremely strict threshold rules. This slow-release technique was designed to stabilize millions of cubic meters of sediment, forcing them to cling to the sloping banks instead of flowing freely downstream. In the fall of 2022, the final mass of concrete was removed. When the reservoir water level drained away, the Pont de la République Bridge, a historic stone transport structure submerged beneath millions of cubic meters of still water for decades, rose back into open air. Its stone arch remained intact. The structure emerged as absolute physical evidence for the existence of an original river system that had once been hidden from view. The destruction of the concrete barrier was complete, but the monitoring system of the INRAE Research Institute filed a conclusion stating that the current flow did not have enough frictional force to carry away the 2 million cubic meters of accumulated sediment. Wild animals would be forced to wait through many flood season cycles for the water to clear the mud, wash away residual compounds, and rebuild the gravel beds before they could return upstream. But the natural survival mechanism surpassed every human safety projection. The moment the water mass was no longer trapped inside the artificial reservoir, the continuous speed of river circulation created an immediate physical effect. The temperature of the entire river system dropped by about 3.6 degrees Fahrenheit in the first summer. That temperature difference was not a random number. It was the extreme physiological boundary that allowed Atlantic salmon to maintain blood circulation and respiratory function. But how could individuals swimming thousands of miles away in the ocean know that the 118-foot barrier had disappeared? The process that allows migratory animals to return to their old territory does not depend on visual memory at all. This system is driven by the ability to memorize the distinctive scent of the waterway. Biological data confirms that Atlantic salmon possess an innate magnetic compass mechanism operating at the molecular level. From the moment they hatch from eggs, their nervous system automatically scans and stores the chemical structure, mineral concentration, and soil composition of the upstream water as a fixed data set. When they move out into the open sea, they use the magnetic network of Earth's crust as a physical compass to swim thousands of miles. But to pinpoint the exact coordinates of their original river at the estuary, they must activate their olfactory receptor system. For 100 years, the concrete wall did not just block the water. It completely sealed off the chemical signature of the upstream zone. The current passing through the reservoir was altered by cyanobacteria and oxygen depletion, causing the original molecular signal to be completely weakened before reaching the ocean. Migratory fish swam to the estuary, but their nervous systems could not recognize the familiar chemical code, forcing them to give up or remain trapped downstream. The moment the concrete mass was dismantled, the circulating current immediately carried the original chemical signal of gravel beds and minerals, whose structure had remained unchanged from 435 miles upstream, sending it straight into Mont Saint-Michel Bay. It took only a few original chemical molecules, mixed into millions of cubic meters of seawater for the neural receptors of salmon to instantly detect the signal. A physiological reflex known as rheotaxis, the automatic instinct of the muscles to move against the current, was activated at maximum intensity. The nervous system directed their bodies straight into the zone where the concentration of chemical molecules became stronger and stronger, allowing them to trace the correct starting line. Only a few weeks after the final physical barrier was removed, the radio sensor system placed along the river recorded a continuous stream of tracking data. GPS records confirmed that 2 salmon individuals swam directly past the coordinates of the former dam foundation and moved 12.5 miles into the upstream zone during the 2022 spawning cycle. This wild population did not wait for the river to break down the full mass of muddy sediment. Driven by the chemical concentration spreading from upstream, they swam through highly turbid water, keeping their muscles in continuous motion to cross the unstable bottom layer and reach the spawning grounds. Even more striking, the monitoring system recorded the immediate return of sea lampreys. These jawless creatures operate a receptor system that tracks temperature bands and mineral concentrations in a similar way. After 100 years of continuously trying in vain to cross the concrete barrier, the current generation of lampreys immediately swam through the newly opened space as soon as the chemical signal matched. European eels moved through muddy, marsh-like zones and directly reoccupied the geographic coordinates where their ancestral populations had lived a century earlier. Field surveys in 2023 confirmed that young salmon born during the previous winter had appeared upstream, proving successful reproduction directly on the imperfect layer of coarse sediment. At the same time, a self-activating biological rebuilding process began across the geological surface on both sides of the riverbank. Plant seed systems took root and grew directly on the mud exposed to air. Within a short period of time, pioneer plant species grew at maximum speed, covering the remains of the structure and re-establishing riparian plant communities without any seeding assistance from management agencies. But this geographic restructuring also pulled the region into localized economic decline. Once the river began operating entirely according to changes in natural rainfall, it completely altered the income sources of local residents. The service economy of boating and tourism on the artificial lake lost its entire physical operating zone. Property values along the water dropped significantly as the still reservoir turned into a muddy area during the dry season cycle. Government compensation procedures only reassessed visible physical equipment on the surface and did not account at all for decades of commercial data and economic continuity lost by the local community. A physical infrastructure that produced direct economic income for local residents was destroyed in order to fully restore the chemical navigation system and biological corridor of wild animals. The Sélune now runs freely for 56.5 miles, releasing sediment mass and natural molecular data directly into the estuary. Biological carrying capacity assessments confirm that this watershed now contains enough physical space to support 5,000 Atlantic salmon. the pioneering individuals have crossed the final geographic defense line. When the artificial industrial concrete mass was removed, the wild ecological mechanism immediately regained control of the system, activating the entire biological navigation machine to overcome every barrier and restore the habitat. The story of the Sélune River is not just a miracle of dismantling engineering or the grandeur of nature's survival mechanism. It places us in front of a brutal trade-off. We deliberately erased an economic system, shattered the livelihoods of tourism businesses, and wiped away the property value of a community that had existed for decades simply to return a pathway home to wild creatures. From the viewpoint of human economic development, many people would call this a step backward, a waste of resources. But from the viewpoint of ecology, it is a miracle, a great act of atonement to Mother Nature. So, if you were the decision maker in power, which side would you choose? Would you keep the hydropower dam and the lake that brings in millions of euros every year? Or accept destroying it all to revive an ecological corridor that had been dead for a century? Was the economic sacrifice of local residents truly worth the return of the salmon runs? Tell me your argument and your logical point of view in the comments below. Like and share this video, and subscribe to the channel so you do not miss the next deep breakdowns of top-tier engineering structures. Goodbye, and see you again.